Hello and welcome. Today I will be showing a test of some new test leads that I've made up. They are based on some big beefy crocodile clips from an old lead acid battery charger and some thick cable. I'll be putting on these connectors. These are your typical banana plugs with a screw terminal at the back, but I won't be using the screw. Instead I will be soldering this because that's just a much better connection in my opinion. Much more reliable. So far whenever I used the screws it didn't work for very long. So I'll take these screws out. So this is 10 gauge wire. It's a bit thicker than what you normally have on a banana plug. Okay, I think this is as good as we're gonna get. Now let's do the other one. And now let's solder it. So this type of banana plug does not really take the solder too easily. You have to heat up the entire connector quite a bit before solder starts adhering to it at all. That's part of the reason why I had to mount this plug in this holder. Otherwise it would just melt the mat I was working on. Unfortunately, I didn't really get good footage of the soldering process itself. I'll just feed in a little more than will fit in. And hopefully it will wick down. This usually takes a while. I'll also add a bit of rosin flux here, which I've got here separately. Stuff works pretty good, pretty well. I think this is pretty good now. Okay. And turn this off. Now I'll clean it up a bit with acetone. Okay, and now it looks nice and shiny. Same with the other one. Now we'll just have to put the sleeve over it. And just push it over. And there we go. Of course you have to line up the hole like this. Same on the other one, of course. So now we've got them terminated. We can plug another one through here if you want. And the other way around, of course. And that's that. So now let's try these leads out. We've got I'm curious to see how well these work for holding a carbon electrode. So what I've got here, this is my old battery powered 12 volt power supply. Basically here's a pack of 4 lithium cells. These are LiFePO cells, lithium iron phosphate cells, not your regular lithium cells. So these are especially designed for very high currents. So these 4 in series can put out up to 70 amps continuously and up to 140 for a few seconds, which is pretty good, I think. I've also recently added a protection circuit for this, which I didn't have for a long time, which is a good idea, but it's not as important with these kinds of cells than it is for others, because LiFePO cells are just much more stable chemistry. They're pretty tolerant of abuse of all kinds. So yeah, now I'm going to show you some arcs made from a 12 volt battery pack pretty much. So here's the actual voltage and current display. You can see we're at about 14 volts actually, because they're fully charged. Their nominal voltage is actually about 13.2 volts, because each cell is 3.3 volts nominal voltage. So now let's plug in these leads. And let me find my electrodes. Here they are. I've got 2 carbon electrodes, graphite electrodes. These actually came from some batteries. You can get these from zinc carbon batteries, not the alkaline type. These are from, I think, D cells, which are the thickest ones. So let's try this, how well these are held. No, doesn't look bad. It's gripping them on the sides, which is what I want. So you can see they don't close all the way because they're holding the electrode here. Same with this one. That looks pretty good. And now let's try them out. Hopefully I can get this on camera properly, because this is gonna get pretty bright. I'll turn on the switch. There we go. And now if I touch these, you can see it draws a huge amount of current. Over here you can see it. What's that, about 60 amps? The electrodes are already red hot. Wow, that's pretty bright. I'll go to the side so you can see the current reading better. Wow, 70 amps. That's insane. I shouldn't do this too long because actually the switch and all of that stuff is not actually rated for that amount of current, just the batteries are. So this switch is probably already stuck. No, it's okay. But of course we're not switching that amount of current with the switch, so it's not under that much load. Of course it's DC also, which isn't good for switches. But yeah, it's insanely bright and insanely hot, but these clamps are not really burning, which is great. And it's still glowing. So I can put them down, of course. As you can see, the voltage on the cells has already dropped quite a bit, but they're just a little bit warm. Maybe 35 degrees, I would guess. So just a moment, I'll get some water so we can cool these off. Here we go. Got some water in here. And now they're cold. And as you might be able to see, now there's some stuff floating on top of it. And some of these flakes are probably graphene. This is one way of actually making graphene, putting very hot carbon electrodes into water basically and making an arc. We can also make the arc inside the water, which I'll show you now. I'll turn the switch back on. So let's try it. I'll put the electrodes underwater, both of them, and I'll touch them. Oh, you can't see the current, sorry. Let me set this up a bit better. By the way, I've also got a 40 amp fuse in here, so if I do this too long, this should in theory blow. It hasn't so far. This is an automotive type fuse, one of the biggest ones you can get. So here we go, let's try this. I'll turn on the switch. I'll dip the electrodes in the water and put them together. As you can see, it's drawing about as much current as before, maybe a little bit less. And we still get pretty much an arc underwater. And now that they're wet, we can get all the water off, of course, by heating it. Now most of it is off. Interestingly, this pretty much generates an arc at only 12 volts or thereabouts. And that's insanely bright again. Okay, I'll pause for a bit, because again, these switches might overheat. And let's put them in the water. Now we've got quite a bit of stuff floating on top of the water. Okay. Let's see if our switch still works. It still does. Okay, that's good. And let's see. Battery is a little bit warm, but again, not really a problem. I'll actually measure it. This is my thermometer. And you can see there's a max reading here. No, not great. Oh, a little bit over 40 degrees it looks like, 45 maybe in some spots. Looks like this is actually a little bit warmer than the rest, maybe. But that's still fine. Not a problem. Of course, these cables are pretty much completely cold. Not a problem at all. These clamps, I don't think they get very hot either. I'll try it again. With my finger on the clamp. And yeah, now it's getting a bit hot. But that's pretty good, I think. Of course, the hotter this gets, the brighter it also gets. And now we've got something I've had for a few times already. I'll cool off this one so we can show you better. Okay. What I wanted to show you is, if I can focus on it. Come on. There we go. It actually produced a little spike at the front, pretty much. This wasn't there before. So to me, it looks like either the graphite is actually melting, which seems unlikely, but it's possible, or there's something else going on here. I'm not sure. But this definitely wasn't there before. I'll strike another arc in front of the camera. If I touch this little spike, it immediately gets extremely hot, of course, and super bright. I'll try to get it to be flat again by pushing it together a bit. Okay, now it looks like it's actually more or less flat again. So the little spike is gone. Hope you can see it. And now I'll try to get it back. Come on. Couldn't get it. Couldn't get what I wanted. I'll cool this off for now. Oop, I was actually making contact there because I didn't turn it off. Let's see how the switch is doing. Now I'm pretty sure it's not doing so well. It's actually okay. Not too bad. But it does definitely feel warm. Yeah, it's pretty warm. Okay, we're back. I think I'm gonna completely discharge the cell now. By the way, the protection circuit seems to be completely cold, which is great. That's how it's supposed to be. Of course, all the 70 or so amps are actually flowing through this protection circuit I showed you before. There's basically a huge array of MOSFETs which switch that current. They basically just switch that current off if it's getting too high. That's all they're doing. And of course they're also switching off if the voltage is too low, because it protects against a few things. But now let's try this again underwater. As you can see, of course it's not getting nearly as hot because the water is cooling it extremely well. And for the same reason it's also not drawing as much current by the looks of it. So it's drawing about 50 amps. And now the voltage is actually too low and the protection circuit has kicked in. So now, as you can see, my voltmeter is not displaying anything anymore because the protection circuit shut the thing off. Yeah. Battery is fairly warm, but it's, again, I don't think it's too much. Let's see. Oh, actually almost 60 degrees in some places. So 60 degrees is pretty much the upper limit of what you should take these up to. But now they're pretty much depleted anyway, so that's not really a problem. So the protection circuit is still holding this thing off. Let's see, maybe it will come back on if I switch this back on. Yes, it does. Because these basically detect if there's still a tiny load on it, and if there is, then they will keep the battery turned off, but as soon as all the load is gone, it will consider turning back on. It won't turn on immediately necessarily, but if there's some time elapsed, it will turn on. And if the voltage is high enough, because these batteries do recover quite a bit of voltage by just sitting there for a few seconds or minutes. So now, if I make an arc again, it will probably shut off very quickly again. Let's try it. Okay, it's still on, because there is still some energy left in the batteries, and now it shut off again. So if you attached a smaller load that didn't draw such a huge amount of current, then it will probably run for quite some time again before it really shuts off. But with such a high load, this is pretty much as much energy as you can get out of it. So now I'll leave these batteries to cool down a bit, and then I'll charge them back up again. And that's pretty much it for today. Thanks for watching. So to charge this box up, what I've got here is a mains lead, which plugs in into the back of this connector. And that's what this other small power supply is for. We can turn this on. And now we've got a switch here, which connects to this power supply and to this boost converter, which is not a good design. I built this years ago when I was pretty much total beginner in terms of electronics. But this thing should in theory be on now. Let's check. Yeah, the main switch is on. And if I press this button, in theory this should be set to the correct charging voltage. So this is a constant current, constant voltage charging circuit basically. And if I turn it on, it will put out the right voltage for this battery over here. So now I will just connect up these ports with these, and then the battery will be charging. So here I've got some short leads, which I basically made just for this. I plug them in. I'll also turn this on and this switch on. And now the positive. And now I'll turn it on and it should be charging. Okay, it's showing the orange light, which means it's in constant current mode, and as you can see, voltage is slowly going up. The current is showing 0, but that's actually not true. That's just because this current meter just measures current in one direction. Of course, when we're charging the battery, current is flowing the other direction it normally is. So here I've got a little clamp meter, which I can use to measure the DC voltage current. Let's put this on, and as you can see, we're charging this at about 7 amps, which is also one of the reasons I've got these types of cells, because you can actually use really high charge currents for them. So you can charge them within half an hour, or actually even less. This power supply just doesn't supply more than 7 amps. You could go way over 10 amps even, or 15 amps for this pack. I haven't tried that, but you could in theory. So now this will take around half an hour, and then this should be fully charged. Current should be pretty stable. And now I'll just leave this charging until it's full. And when it is, this should turn over to constant voltage and not overcharge the cells. Okay, looks like it's done. There we go. And again, it's slightly warm, that's just from the converter here, mostly, but the battery pretty much completely cold. Okay, that's it.